This is Homeschool 101, a collaboration between ABS Television and the Ministry of Education. Stay attentive and attempt all activities. And now, today's lesson.
Welcome back to Mathematics Homeschool 101 for our third lesson, which is on measurement. I am your teacher, Mrs. Hughes Thornhill, and at the end of every lesson, you are left with a few practice questions to test your knowledge. So before we go any further, let's have a look at the practice problems from the previous lesson. Question 1. After eating dinner, the Thomas family left a generous tip of 15% for their waitress. If their meal cost $180, what was the tip left? So let's read the question again, and this time highlight the important parts. After eating dinner, the Thomas family left a generous tip of 15% for their waitress. If their meal cost $180, what was the tip? So when we're doing this, we want to remember that once we can find 10%, we can pretty much find any percentage. So let's start with 10%. So 10% of 180, we know that that's going to be $18. So if 10% is $18, then 5% is going to be half of $18, and that's $9. And so our 15% is going to be the addition of that. So that's $27. Okay. Question 2. A lady bought a car for $15,000 and sold it for $12,000. What was the percentage loss on the cost price? Again, a lady bought a car for $15,000 and sold it for $12,000. What was the percentage loss on the cost price? So, bought the car for that, sold the car for that, and we want to know the percentage loss on the cost price. So, in order to find the loss, we're just going to have to do a subtraction. So we have 15,000, and if we take away 12,000, we are left with 3,000. Okay, so this is our loss. And just as the question said, what was the percentage loss on the cost price? So our loss, which is 3,000, we're going to put that on the cost price. The cost price, not the selling price, so it's going to be over 15,000. Right? And in order for us to make it a percentage, remember we just multiply by 100. So these zeros get rid of each other. We have 3 over 15, and we have times 100. We can even get rid of this. 3 into 3 goes once, and 3 into 15 goes 5 times. So we're left with 100 over 5. And if we divide 100 into 5 parts, we're going to get 20%. Okay? Question 3. After $600 was invested at simple interest for 2 years, it earned $72. What is the rate of interest per annum? Let's read again. After $600 was invested at simple interest, yes, for 2 years, it earned $72. What is the rate of interest per annum? So remember, we're talking about simple interest, and we have to remember that formula. So the simple interest is equal to principal times rate times time divided by 100. But in this case, we are looking for the rate. And if you remember the rate formula, that's the interest times 100 divided by the principal by the time. So let's just identify the parts. So here, we know that this amount was invested, and so that is the principal. our time is always in years, and this is the interest earned. And so R is equal to the interest, which is $72 times 100, and we divide that by the principal, which is $600, times the time, which is 2 years. So our zeros cancel each other there, and we end up with, well, we could even go further, but let's just use what we have here, $72 over 2, and we do that division. So 6 times 2 is 12. All right, so 12 into 72, and we end up with 6%. Okay. A flat screen television costs $2,000 cash. If the television is bought on hire purchase, a consumer must make a deposit of $900 followed by 12 monthly payments of $120. How much can be saved if the television is bought at the cash price? All right, so let's read that again and highlight the important parts. A flat screen television costs $2,000 cash. If the television is bought on hire purchase, a consumer must make a deposit of $900 followed by 12 monthly payments of $120. How much can be saved if the television is bought at the cash price? So we need to find out what the hire purchase price is going to be. And so we're just going to multiply our monthly installments by 12 because it was for 12 months. And we can't forget to add the deposit because we had to pay a deposit in order to even collect the item on hire purchase. So we have 120 times 12. And we know that 12 times 12 is 144, and then we just add the 0. And so that's 144 and the 0. And we also have to add our deposit, and our deposit is $900. And when we add those, we get $2,340. So if the hire purchase price is $2,340, in order for us to find out how much would be saved if we had bought the television by cash, we would just have to do a subtraction. And so from this, we just take away the $2,000, and it's clear to see that the answer is going to be C, which is $340, okay? So let's get into our measurement topic, which, well, before we continue, I have here the CSEC list of formulas, and it's just so you have a glance at what you expect to see before you see the actual question. So this is just a list of formulas. I'm not going to go through it. But as you can see, there's a lot of formulas there, but every single formula that you may possibly need would not be on such a sheet. All right, so since we're doing measurement, I've actually highlighted a few formulas that we're going to be using. And these formulas are the area of a square or rectangle, which is the length times width, the area of a triangle, which is half base times height, the circumference of a circle, which is 2 pi r, the area of a circle, which is pi r squared, the arc length, which is equal to the angle over 360 times 2 pi r. So the arc length here in this case, the arc is called AB. So our arc is this, the outer side of our circle. And the angle, as you can see, is here on the inside. And of course, we have our radius, okay? We're also going to be looking at the area of a trapezium, which is half of A plus B times H. And all those letters obviously have meaning. So where A and B are the lengths of the parallel sides, and h is the perpendicular distance between the parallel sides. Now that sounds like a whole lot, but the diagram here pretty much depicts what the sentence before is talking about. We're also going to be looking at the volume of a cylinder, which is pi r squared times the height. And we're going to be looking at the volume of a prism. Now, it doesn't matter what prism it happens to be. Here I have an example of a prism that's based on a square, which we can call a cuboid. And so this is equal to the area of the face times the height. So where A is the area of the cross section and H is the perpendicular length. So let's just take a look at perimeter, because we talked a lot about formulas, but do we really know what they mean? So perimeter here, well, perimeter in any instance is considered the distance around any shape. And the units of measurements are always just without any power. It's a single power. So it's centimeters, meters, etc. So here we have a rectangle. So if we wanted the perimeter of this rectangle, we're talking about the distance around the rectangle. We've also talked about circles. Notice that the red is going around there, depicting the perimeter of the circle. This is also known as the circumference. So the circumference of a circle, we don't necessarily say perimeter of a circle. We say the circumference, and so that's that. Now, how does measurement apply to our daily life, or just in life in general? Maybe not our personal lives, but in general. So here we have a yard, and the perimeter is depicted there as the fence. Okay, so we talk about the perimeter of the yard. We also have a butterfly in a picture frame. So here the picture frame is what we would consider the perimeter there. Area. Area is the space inside any two-dimensional shape. The unit of measurement used is always squared. Example, centimeters squared, meters squared, etc. Right? Now notice here we have a rectangle, but this time we're talking about the space inside. And for this particular rectangle, we were able to even divide it into parts, maybe based on the measurement. So if I were to say the area of this particular rectangle, the area here would be 8 centimeters squared, if that happens to be the unit of measurement. Because if you count, there are 8 squares in this rectangle. Here we have a triangle, and this happens to be a right-angled triangle. And you will also notice that this yellow triangle happens to be in a rectangle. So all that is telling you is that we can get at least 2 triangles from any rectangle or square or the like. And for this particular one as well, we are able to to count the space that is inside to find out how much it would be worth or valued at, right? So remember, the area is just the space inside the shape. And here we have a similar yard to the one that was shown in the perimeter, except this time we're not concerned about the fence, we're concerned about what's inside the fence. So that red area there is what we would consider the area. Here we have a floor pattern of tiles, and we're just zoning in on the inside there of the pattern tiles. And notice you also have squares happening in between there. And you will see some triangles as well. And if we had put 2 of those triangles together, we'd be able to get a complete square. And here's another example. But this one has measurements on the outside, 10 and 5, 10 and 5. So of course, with our knowledge of finding the area, so if we had to find the area of this particular diagram, it would be 10 times 5, which is 50. We're also going to zone in on volume. And volume is the amount of space a substance or object occupies in any 3-dimensional shape. The unit of measurement used is always cubed. So take note, because when you're finding volume, whatever unit of measurement you're using, it must always have that power of 3. Otherwise, it won't be considered as volume. So here we have a cylinder. And when we talk about volume, remember, we're talking about the space that's inside of this. So how much can it hold? Here we have a cuboid. And this is something we're all familiar with. So we have a water bottle. So the water bottle has a particular shape, but how much water can it possibly hold? And we have a popcorn box, okay? So how much popcorn can fit in this particular one? And you may be familiar with this sort of carton. There are different sizes available. And so you choose the size that you want based on the amount of popcorn that you would want. All right, so let's talk about perimeter again. So first question, the perimeter of the figure below is, remember the perimeter is the distance around the shape. And so we have to use that knowledge there in order to find the perimeter. But if you look, you'll notice that this shape has 1, 2, 3, 4, 5, 6 sides, but there are only 4 measurements. So we're missing 2 measurements. Okay, so that's the first thing that we need to do. We need to find measurements for the 2 missing sides. And how do we do that? So we know that the bottom of this shape is 10 centimeters. And above that, we have a measurement of 6 centimeters. And so because these are going horizontally, and we can find the other horizontal side. Because the entire thing is 10, a part of it is 6, so what is left? 6 plus what gives us 10? 4, all right? Now we look at the vertical sides. We have 9 centimeters, 2 centimeters, and we don't know the other side. But we know that from top to bottom, it's going to be 9 centimeters. And if a part of it is 2, if we take 2 from 9, we will get 7 centimeters, right? So now that we have all of the sides for our figure, we are able to find the perimeter. So let's just go ahead. So we're going to add 9 plus 10 plus 2 plus 6 plus 7 plus 4. And I'm just going to add CM at the end. We can't forget our measurement. And when we add those, we are going to get 9 plus 10 is 19, 19 and 2, 21, 21 and 6, 27, 27 and 7, 34, 34 and 4, 38. Okay, so our answer there is B. That was simple. Question 2. The circumference of a circle is 44 centimeters. What is the radius of the circle? The circumference of a circle is 44 centimeters. What is the radius of the circle? Now this question would have been perfect if they had asked us to find the circumference. However, they did not ask us to find the circumference. We were given the circumference, and so we have to use that information in order to find the radius of the circle. So let's start with the circumference of a circle formula. And just take note of how the answers look, okay? So there's some times where we don't actually have to work in the value of pi. Pi is stated there, so they don't want the final answer. They want us to arrive at an answer that looks like one of the options. So the circumference of a circle is equal to 2 times pi times r. We have the circumference, and the circumference is 44. 2 times pi, and we need r. So this is a bit of algebra. We haven't touched that quite yet, but we have to now manipulate this formula in order to find our answer. So because 2 pi is attached to the radius, and radius is what we want, we have to do the opposite of whatever is happening to it. And when these things come together, it's representation of multiplication. And the opposite of multiplication is division. And so we're going to divide both sides by 2 pi. So if I divide over here by 2 pi, I know that they're both gone, yeah? And if I divide over here by 2 pi, I now have what r is equal to, because r is all I have left on my right side. So r is equal to 44 over 2 pi. So we have 44 over 2 pi, but that's not quite done yet, and we actually don't see our answer over there just yet. But you'll notice that 2 can go into 44. And so if I divide 2 into 2, that's gone. 2 into 44, that's 22. And so we're left with 22 over pi. So r is equal to 22 over pi, and we see our answer there at B, 22 over pi. Question 3. The diagram below shows a sector of a circle with center O. The length of the minor arc AB is 6 centimeters. Read again. The diagram below shows a sector of a circle with center O. The length of the minor arc AB is 6 centimeters. What is the circumference of the circle? So this one now wants the circumference of the circle, but they only gave us information about the yellow part of the circle, the sector that they highlighted there. So first, we're going to have to find out how many 45 degrees angles are in the circle. And we know that we're going to be dealing with 45 degrees because it told us on the side here that the angle AOB is 45 degrees. So this here is 45 degrees. So how many 45 degree angles can we get in this circle? Now we know that the angles in a circle add to 360 degrees, and so the only way to do this is to divide the 45 into 360. So 360 degrees divided by 45 degrees. How many 45s go into that? So that is going to give us 8. So you can do a little bit of trial and error. Maybe you'll have to do a reverse thing where you find out, you multiply 45 on the side times some number in order to get the 360. But the answer here is 8. So we know that there are going to be 8 of these yellow circles happening, or sectors, sorry, happening within the circle. So if there's 8 of these that occur, and they told us that AB is 6 centimeters. This is a part of the circumference. That means we can now multiply 6 times 8. Just add in our CM. 6 times 8, and we're going to get 48. And that's our answer there at D. Okay? That was simple. Not so bad. Question 4. We're now focusing on area. So a square has the same area as a rectangle with sides of length 9 centimeters and 16 centimeters. What is the length of the side of the square? Again, a square has the same area as a rectangle with sides of length 9 centimeters and 16 centimeters. What is the length of the side of a square? I'm a visual learner, right? So I like to kind of draw what I'm talking about. So I would probably start with drawing this rectangle that they told us about. So there's some rectangle, assuming it's nice. It's measurement 16 and 9. Now, they're saying that we have a square that has the same area, but we don't know the sides. So the first thing we're going to have to do is to find out what the area of the rectangle is in order to find out the sides of the square. So the area of a rectangle is length times width. And so if I start area of the rectangle, length times width, the length is, let's say 16, and the width is 9. Doesn't matter which one. And so we just multiply 16 by 9, and 16 times 9 is actually 144 centimeters. So the area of the rectangle is 144 centimeters. Now, this also means that the area of the square is 144 centimeters squared. Okay? Now, what do we know about a square? A square has equal sides. So because the square has equal sides, we're going to have to find the square root of 144. All right? So if we find the area of the square, which we know is length times width, but we have the area, which is 144, we're going to have to find the square root, as I said, of the length and the width, 144, because both the length and the width have the same value. And so even if I left the LW here, if I found the square root of here, the square root of 144 we know is 12 centimeters. And so that means the measurements on the side of the square is 12 and 12. Okay? Good. So our answer there is B, which is 12 centimeters. The area of a triangle is 36 centimeters squared, and the length of its base is 8 centimeters. What is the perpendicular height in centimeters of the triangle? Again, the area of a triangle is 36 centimeters squared, and the length of its base is 8 centimeters. What is the perpendicular height in centimeters of the triangle? So I have some triangle. Doesn't matter what it looks like really, as long as it's a triangle. And I know the area of it is 36. So the space inside is going to be 36 centimeters squared. I have the base of the triangle, which is 8 centimeters. And I want to know what the perpendicular height is. So I need to find the height of the triangle in centimeters. So there's more than one way to approach this question. Using the formula to find the area of the triangle, we can either guess and check the answers, or we can rearrange the formula to find the height. Okay? So we're going to do both methods, but I'm thinking the guess and check is probably the easiest method of them all. So we know that the area of a triangle is half of the base times the height, right? We have the area of the triangle. The area of the triangle is 36 centimeters squared. And we have the base of the triangle, which is 8, but we do not know the height. So if we halve 8, we get 4. Still left with the height, and 36. So we need to ask ourselves now, 4 times what gives us 36? 4 times what gives us 36? And when we look at our options there, is it 4.5? No. Is it 18? No. And it's not 6, so our answer there is D, which is 9, because 4 times 9 gives us 36 centimeters squared. Okay, so that's the first method where we guess and check. So we utilized our answer in order to find the missing part, which was the height. But if you really didn't think in that way and you were really good at manipulating your formulas, you would start with the formula as it is, half base times height, and do a little algebra to rearrange it to find what the height is going to be equal to. So we'd get rid of the 2, well, the half, because we don't like fractions, do we? So we get rid of the half, and in order to get rid of that, we'd have to multiply both sides by 2. So if I multiply by 2 and I multiply by 2, I get 2 times the area is equal to the base times the height. And because we're looking for height and base is being multiplied, we would divide both sides by the base. And that's gone. And so the height is equal to 2 times the area over the base. So again, they gave us the area, which is 36 centimeters squared. So if I have 2 times 36 and I divide it by the base, which they gave us is 8, 2 times 36 is going to give us 72, and we divide that by 8. And if we divide that by 8, 8 into 72 goes 9 times. So we still get the same 9 centimeters. So it doesn't matter which way you approach the question. It just depends on the way you would have thought about it. One way may be easier than the other. But again, just go with what's comfortable for you. Either way, once the process is right, you should be able to get the correct answer. Okay? Question 6. The diagram below, not drawn to scale, consists of a triangle and a rectangle. The height of the triangle is 3 centimeters. What is the total area of the figure? So this kind of looks like a house, doesn't it? Well, like the side profile of a house. And so this is, another example of where measurement and even just shapes and angles are in our real life, our everyday life. So again, the diagram below, not drawn to scale, consists of a triangle and a rectangle. The height of the triangle is 3 centimeters, as you can see there in the middle. What is the total area of the figure? So this diagram consists of 2 shapes that we're actually familiar with. And so all we'd have to do in order to find the total area of the shape is to find the area of each part that we know. So we know how to find the area of a triangle. And the area of a triangle is, of any triangle, is half base times height. And do we know what the base is? Of course we do, because we have the length there of the rectangle, and because those 2 are parallel, here is also 8. Okay, so the base of the triangle is 8, and the height of the triangle is 3. Half of 8 is 4, and 4 times 3 is 12. Don't forget your squared. Now we have the area of the triangle. We're going to go to the area of the rectangle, which is length times width. The length of the triangle here is 8. The width is 5, or vice versa. And 8 times 5 is 40. And so all that's left to do is to add both parts. So the area of the figure is going to be, if we call that A1 and this one A2, is going to be the area of the first part plus the area of the second part, which is 12 centimeters squared plus 40 centimeters squared. And 12 plus 40 gives us 52 centimeters squared. See, we're just flying through these questions. So you can see your answer there in the option. That's D, 52 centimeters squared. Okay? Next question. What is the area of the figure below? What is the figure below? The figure below is a trapezium. So we know the formula for finding the area of a trapezium. And that is half of A plus B times our height. Half of A, what is A? A is 6, B is 14. So remember, because remember, A and B are the parallel sides. So 6 plus 14 times our height. Our height here is 8 centimeters. And notice they didn't give us the measurement for the side here or the side here, but that the height is labeled on the outside. It's important to remember that even if measurements were attached there, the height is always the vertical vertical line. So even if the height were depicted in the middle of this trapezium, it would be done something like that. Okay? Let's continue. So just working through the formula. What is 6 plus 14? 6 plus 14 is 20. And we're going to multiply that by 8. Half of 20 is 10, of course. And multiply 10 by 8. We can already see the answer there. 10 times 8, 80 centimeters squared. Don't forget the square. If you remember, if you don't have your unit of measurement there, the answer wouldn't be 100% correct. All right, so the answer there is C, 80 centimeters squared. Question 8, the area of the circle in centimeters squared is. Take a look at the answers again. Notice they all have pi on there, so they never expected you to work using the value of pi. So they just meant keep pi the way it is, and what is the answer? So the area of the circle, how do we find the area of a circle? Remember, these are things that are on your formula sheet, so if you don't remember off the top of your head, you can always refer back to your formula sheet that is provided to you. So the area of a circle is equal to pi r squared. And what does it mean for something to be squared? We just multiply it by itself. And so that means it's pi times the radius times the radius. Now, if we look at the circle, we'll notice that we have a measurement going through the center that goes, so it goes from circumference to circumference, goes from either end of the circle, and it gives us semicircles, right? But this is not the radius, so don't be fooled and end up using the 10 because the formula asks us for the radius. So the radius is just going to be half of 10. So half of 10, well, half of whatever the measurement happens to be, but in this case, it is half of 10. And half of 10 is 5. And so we just use pi times 5 times 5 because it's radius squared. And we all know that 5 times 5 is 25. And so even if I did it like this, pi 25, but we don't really write like that. It looks much better if the pi was on the other side. So 25 pi, and you can see your answer there at C. 25 pi. All right, so moving into volume and going really quickly. So please take time and make sure this is sinking in. The diagram below, not drawn to scale, shows a cylinder with height 5 centimeters and a radius of 4 centimeters. What is the volume of the cylinder? Again, taking a look at the options, notice that pi is in there, so they never expected us to work through pi. And let's just read the question again. The diagram below, not drawn to scale, shows a cylinder with height of 5 and radius of 4 centimeters. What is the volume of the cylinder? Okay, so the volume of a cylinder, let's just do it there. The volume is equal to the area of the face of the circle times the height. In this case, this shape is made out of a circle. So the circle is what we're going to have to find the area of, and then we multiply it by the height. What is the area of a circle? The area of a circle is pi r squared, and we're going to multiply it by the height. Keep in pi, the radius is given, which is 4. So 4 times 4, don't forget, that's the r squared, so radius times itself, times the height. And in this case, it is 5 centimeters. Pi times 4 is 16. And if we multiply 16 by 5, we're going to get 80. And because we're doing volume, we can't forget the cubed. But again, you know, we could swap those, or, well, the answer is very clear there. So the answer there is A, which is 80 pi centimeters cubed. Now, even looking at this, we know that we could not have selected D, because if we had selected D, that means that we had forgotten the height. In this case, the area of the circle, because the area of the circle is 4 times 4, which is 16, so we would have been able to eliminate that. Okay? Question 10. The volume of a cuboid is 245 centimeters cubed, and the height is 5 centimeters. If the cuboid has a square base, what is the length of one side of the base? So we have some cuboid, but this cuboid was created out of a square. Remember, when you think square, we're talking about same sides, equal sides, okay? So we want to know what is the length of one side of the base, which is of the square. So again, the volume formula for to find the volume, it's always the area of the face times the height. All right, so in this case, again, the face is a square, and the area of a square is length times width. And now, because we're finding the volume, we have to multiply by the height. They gave us the volume, which is 245. And of course, centimeters cubed. We don't know the length, we don't know the width, but we do know the height. So length times width times the height, and our height is 5 centimeters. Now, what we're going to do is, because we're trying to find the sides of the square, and we have two unknowns there, which in this case can be considered as 1 because they're both the same thing. We need to get rid of the 5, and the opposite of multiplication is division. And so we would divide both sides by 5, because what we do to one side must do to the other. We can't forget that. So that gets rid of that. We're left with length times width on the right side. And if we divide 5 into 245, we're going to get 49. Okay, 49 centimeters. So again, since the base is a square, and that means that the length and the width are equal, we have to find the square root and the square root of both sides, because again, the L and the W are valued at the same. So we could consider them to just be L or just be W. So if we find the square root of both sides, the square root of 49, that is now going to give us 7. And so the length or the width is equal to 7 centimeters. Hopefully you would have found these questions quite simple. Hopefully you've noticed that in any case, because we're doing measurement, we always had to refer back to our formulas. The formulas are important. Having the formulas are one thing, but knowing how to use them are another thing. Remember to read the questions carefully, because it may be simple, but if you don't understand the question, you won't be able to select the right answer. So you want to be able to read, understand, have your formulas, and know how to use your formulas. Right? So here we have 2 practice questions for you. Always remember to apply your test-taking strategies when doing multiple choice questions. Read the questions carefully and utilize the formulas given on your CSEC formula sheet. See you for our next episode when we'll dive into some algebra. Continue to stay safe and happy studying.
You've been watching Homeschool 101, a partnership between ABS Television and the Ministry of Education. Thank you for viewing this lesson. Join us again next time.